Hello students. For my students in my class during the COVID-19 closures, this is the week of April 27th. This is assignment 1. If you're watching this on YouTube, this is our Unit 3 Lesson 8 handout video. So this is the video where I'm going to work through all the problems for my students, and you can follow along with us. If you're watching this on YouTube and you're not one of my students, but you'd like to get the handout, I've put a link, a Google Drive link in the description. There are 17 problems on this handout, and they are varying types of problems. There are binomials. There are problems where we'll just find the greatest common factor. There are difference of squares, sum and difference of cubes, and then there are some cubic polynomials that we will do at the end. So this should be a good practice for our lesson 8. This is also going to be good practice for our next lesson this week, which is rational expressions, simplifying, multiplying, and dividing. You do need to know how to factor to be able to do work with these rational expressions for Unit 4. The very first thing you want to do in any factoring situation with polynomials is look for a greatest common factor. Anytime you can take out a greatest common factor, that's going to make your problem a lot easier to deal with, to work with. And in this particular problem, that's the only thing we can do with it. If you have a polynomial, binomial, trinomial, any sort of polynomial, and every term in that polynomial has the same variable, whether it's differing degrees or not, if it has the same variable, you can pull that variable out as a greatest common factor. The greatest common factor is going to be the variable with the lowest exponent. In this case, it's an exponent of 1. So I'm going to take out a p at the very least. I want to look at my 25 and my 7, my coefficients, and see if they have a common factor that's not 1, and they don't. So the p is actually the only thing I can take out of this binomial. And then when I do that, remember this is opposite of distributive property. I'm pulling out this p, and that means that I'm going to divide each of these by the p, and that's what's going to be left in parentheses. So 25p squared divided by p is 25p. And then 7p divided by p is plus 7. So this is the factored version of this binomial. If you were asked to find the zeros, though, you would take each of these factors and set it up equal to 0. So I would set up p equals 0. So 0 would be one of the factors. And then I would set up 25p plus 7 equals 0. And then I would just solve for p. So 25p would equal negative 7 divided by 25. P would equal negative 7 25ths. So my zeros, or my factors, or sorry, not my factors, my x-intercepts, or my roots, we can call them any of those 3 words, would be at x equals 0 and x equals negative 7 25ths. So depending on what you're asked to do, if you're asked to factor it, this would be the answer. That's the factored form. If you're asked to find the zeros or the roots or the x-intercepts, then this would be your answer. Okay, number 2. Again, what you want to do with any type of polynomial when you're factoring it is look for a greatest common factor. If the value here, if the coefficient of this first term is 1 and you've got this quadratic trinomial, then you can't take out a greatest common factor. The greatest common factor of these is going to be 1. Also, if you have a constant at the end. So anytime you have one of these trinomials that we're used to looking at, there's no greatest common factor in this one. So the next thing I want to do is I want to say, okay, I know that this is a quadratic trinomial. I'm going to check to see if I can factor this to 2 binomials, and we will be able to. What we want to do is we want to look at this last term, and we want to look at this middle term. And I'm not going to go through these for every problem, but I'm going to go through it for this first one. I need a factor pair for 25, and it can be positive, negative numbers, that when I combine them, I get negative 26. Well, negative 25 times negative 1 would give me positive 25, and negative 25 plus negative 1 will give me that negative 26. So these are the things that go in the parentheses. I'm going to have a minus 25 and a minus 1, and then my j goes here. So if you remember, if we have a coefficient of 1 right here, that's how we would factor these into two binomials. Now, again, this is my factored form. So this is the answer if you're asked to factor. If you're asked to find the zeros, then you would set up each of those equal to 0 and solve for the variable. So my roots or x-intercepts would be 25 and 1. So it depends on what you're asked for. If you're asked for factored or if you're asked for your x-intercepts. Number 3 is another trinomial where the a value is 1. Remember, these trinomials have an a value, a b value, and a c value. And sometimes we have to use quadratic formula. I don't think I gave you one where you have to do that today. But sometimes we have to use quadratic formula if we can't factor it into binomials. This one we can. A factor pair for 144 is 12 and 12. 12 plus 12 equals 24. So that's one way we could write it. We could also write, since it's times itself, we could write it like that. And then our only x-intercept is going to be at -12. I did want to point out one more thing on this one. Since we have this 2 here, that means that the graph would bounce at -12. Okay, number 4. Same thing, a value is 1. 4 times 3 is 12. 4 plus 3 is 7. So this is going to be x plus 4, x plus 3. So I have two x-intercepts. One is at -4 and one is at -3. This is the factored form. These are the roots. All right, 5 times 3 is 15 and 5 plus 3 is 8. So this one's going to be x plus 5 and x plus 3. So my zeros are at -5 and -3. All right, number 6, on first glance, it looks like this one has an a value, that's not 1, so I'm going to have to use a different method to factor this. But if I look at it a little bit closer, I see that these coefficients are all even numbers. So that means I can take out a 2 if they're all even numbers. And taking out a 2 as the greatest common factor leaves me a trinomial that has an a value that's 1. So then maybe I can factor this into two binomials. And let's see, -16, 8 times 2, +8, times -2 would give me that -16, and it would give me the +6 if I add those two together. So then my x-intercepts would be -8 and +2. Now, number 7, there is no greatest common factor I can take out of this. My a value is not 1. So what I need to do is use what we call the AC method, which is a times c. So I'm going to take the 5 and the 2 and multiply those. I'm going to use the 10. After multiplying the 5 times the 2, the 11 is my middle term. So I need something that when I multiply it, I get 10, and when I add them, I get 11. Well, that's going to be 10 times 1, 10 plus 1. Now, instead of going ahead and saying, okay, that's going to be x plus 10, x plus 1, that won't work. What I have to do is I have to rewrite this trinomial, splitting this middle term into 10 and 1, 10x and 1x. So I'm going to rewrite it like this. So this 11x just gets rewritten as 10x plus 1x. Doesn't change the value or anything. It's just rewritten a different way. Now what I do is I group these. Now when I have 4 terms like this, sometimes I can group them. If you have a ratio between this coefficient and this coefficient that's the same as the ratio from this one to the constant, then you can group these and factor them that way. What I'm saying is 5 to 10 is the same as 1 to 2. So if that happens and those are equal, then you can group these. Okay, so what I would do after I group them into two binomials is I'm going to take the greatest common factor from each binomial. The greatest common factor here is going to be 5x. And when I take out that greatest common factor, I'm left with x plus 2. The greatest common factor could just be 1, and it is in this case. So I'm going to take out a 1. and I'm left with x plus 2. If I get the same thing here and here, that is a greatest common factor between these two terms, and I can take that out. In other words, that's going to be one of my binomials. And my other binomial is going to be what's left over, which is the 5x plus 1. So this is actually the factored form of this trinomial. And then if I want to find the zeros, I set up x plus 2 equals 0. So x equals negative 2. And then I would also set up 5x plus 1 equals 0. X would equal negative 1/5. So these are my two roots or x-intercepts. Number 8 is another trinomial where my a value is not 1 and there's no greatest common factor I can take out of these. So I know I'm going to be rewriting this as 2x squared, and then I'm going to have two things in here. They're going to both have x's. I don't know yet what they're going to be, and then I'm going to have a plus 30 on the end. So I'm going to have to split this middle term into something. When I multiply that 2 times 30, I get 60. I know that 12 times 5 is 60, and 12 plus 5 is 17. So if I split this into 12x and 5x, that would work for the 17, and it would work for the 60 when I multiply the 2 times 30. So again, if 2 over 12 is the same thing as 5 over 30, which it is, these are both 1/6, then I know I can group these and take out my greatest common factors, and then I'll be able to factor that way. So let's take out greatest common factor here. That's going to be 2x, and I have x plus 6 in parentheses. Here it's going to be plus 5. X plus 6 in parentheses. If you get the same thing here, you know you did it right. My first factor is x plus 6, and my second factor is going to be those two numbers there. So this is factored here. If I need to know my x-intercepts or my zeros, x is going to equal negative 6, and let's see, that's going to be 2x equals negative 5, so x is going to equal negative 5/2. So as we move into the next type problem, numbers 9 through 12 are all binomials. So we no longer are dealing with trinomials, but these are a particular type of problem where we are still going to be factoring them into two binomials because we have perfect squares. 9 is a perfect square, x squared is a perfect square. So if you have two perfect squares and you have a minus between them, this is called difference of two squares. And what you would do is you would take the square root of each of these. So the square root of 9 is 3. Square root of x squared is x. You put those numbers in the parentheses, or those terms in the parentheses. In one set of parentheses, you have a plus, and the other one, you have a minus. So this is how you always are going to factor difference of two squares. 9 minus x squared is 3 plus x, 3 minus x. Now you cannot switch these around because one of them is a minus and that's not commutative. You cannot switch these terms around. This 3 minus x does not equal x minus 3. When you start doing rational expressions, though, sometimes you will need to switch the 3 and the x around. And if you want to do that, what you can do is if you take out a negative 1, so if you have a 3 minus x, and you take out a negative 1, then that ends up being negative 3 plus x, because this divided by negative 1 is negative 3. Negative x divided by negative 1 is positive x. So then you can switch these around because negative 3 plus x is the same as x minus 3. So keep that in mind when you start the next lesson. If you need, for some reason, to switch these around and they have a minus, then if you take out a negative 1, you can switch them around. Now, 3 plus x is the same as x plus 3, because addition is what we call commutative. In other words, I can switch these numbers around and it doesn't change the value at all. But if I wanted to change these, then I could take out that negative 1 and write it like that. I have another difference of two squares, x squared and 49. So again, this is going to be two binomials. I'm going to have a plus in one and a minus in the other. The square root of x squared is x. The square root of 49 is 7. So also I didn't do the roots, but that would mean that the roots would be 7 and negative 7. This one looks a little bit different, but it's still the difference of two squares. What I'm asking myself is what times itself equals y to the 6th and what times itself equals x squared? Well, y to the 6th equals y to the 3rd times y to the 3rd. So it equals y to the 3rd times itself, because remember you add the exponents. So this is still difference of two squares. I'm still going to have a plus in one parentheses and a minus in the other. In this case, I'm going to have a y cubed and an x in each parentheses. And of course, on this one, I'm not going to state what the zeros are because I have two different variables, and this is just a different type of problem. All we're doing here is just factoring it. Number 12, same type of problem. I have a 49 and I have a 16x squared y squared. So let's go ahead and just do our parentheses. I have a plus in one and a minus in the other. Square root of 49 is 7. So that's the first one. The square root of 16x squared y squared is 4xy. That times itself would be 16x squared y squared. Again, I'm not stating any zeros or roots here because I have two variables. So this is not that type of problem. This is just a factoring problem. So number 13 is what we call sum of two cubes, and we did this in lesson 8 video. So depends on what you're asked to do. If you are asked to factor, then you can leave it as a binomial and a trinomial. If you are asked to find the roots, then you have to take it a step further, which we're going to do. First thing I'm going to do is I'm going to rewrite this and switch these, just because I like my variable on the left if I can. Because this is a sum of two cubes, I can switch them around because it's addition. So what we need to do is we need to find out what our first value is and what our second value is, and what they are is the cube root of each of these numbers. The cube root of 8g squared is 2g. And then the cube root of 125 is 5. So in my parentheses, and if you don't remember this, you want to go back to that lesson and look at where we get these numbers. My first parentheses is a binomial, and it is these two numbers added together, 2g plus 5. So I could get one of my roots by setting this up equal to 0. The other one is a trinomial. The first term is going to be this thing squared, so that's going to be 4g squared. The second term is going to be minus, and it's going to be this times this, so that's 10g. And then the last one is plus, and that's the second number squared, so that's 25. So if all you're asked to do is just factor it, sometimes you could leave it like this, depending on what website you're using or what you're asked to do. You could leave it like this. If you're asked to find the zeros, you can't leave it like that. You've got to use quadratic formula here because we can't factor this. There's 4 times 25 is 100. There's no numbers that when I combine them, I get negative 10, and when I multiply them, I get 100. So I would have to use quadratic formula here, which we're going to do. So my A value for quadratic formula, my A value is 4, my B value is negative 10, and my C value is 25. And if you remember quadratic formula, it is x equals, it's going to be the opposite of b plus or minus square root of b squared minus 4ac, all of that over 2a. It's not fun to work with, but we need to do it to find those imaginary roots. Okay, so let's start plugging in here. So x equals, the opposite of b is 10. The opposite of negative 10 is 10. Plus or minus square root, negative 10 squared is 100, minus 4 times 4 is 16, times, let's see, is that going to be, well, 4 times 25 is 100, times 4, make sure I did that right. Yep. 4 times 25 is 100, times 4 is 400. And then all that over 2 times a, which is 8. All right, so let's keep working. X equals 10 plus or minus. This is going to be the square root of negative 300. And that's all over 8. Okay, so let's think about what the square root of negative 300 is. Square root of negative 300 is going to be the square root of negative 1 times square root of 100 times square root of 3. Okay, so square root of negative 1 is I. Square root of 100 is 10. So that's going to be 10I root 3. All right, so let's rewrite this one more time. X equals 10 plus or minus 10I root 3 over 8. Okay, so the last thing I can do is, all of these are even numbers. I can actually simplify this a little bit by dividing everything by 2. So that means X would equal plus or minus, so positive or negative, 5 plus 5I root 3 over, and then divide that by 2 also, 4. So this is 2 roots right here. This is positive this and negative this. And then my other one, and I've got X, you can use X or G, it doesn't matter. My other one is going to be, I'll use an X. 2x plus 5 equals 0. 2x equals negative 5. And I did actually graph this, and you could see that one of the roots was at negative 2.5. X equals negative 5/2, which is that negative 2.5. So if you're asked to factor it, you can do this. If you're asked to find the zeros, there are 3 of them. You can see I've got an exponent of 3. So there are 3 zeros. 2 of them are right here. They're imaginary, which means if you graphed it, you couldn't see them. And then one of them is here. And if you do graph this, you will see that one of the roots is at negative 2.5. The other 2 are positive 5 plus 5i root 3 over 4 and negative 5 plus 5i root 3 over 4. Okay, number 14 is sum of 2 cubes again. So I need to figure out what the cube roots are of these 2 numbers. The cube root of 27a cubed is going to be 3a. The cube root of 64 is 4. So my first set of parentheses is going to be 3a plus 4. And then I'm going to square this, 9a squared. I'm going to multiply these together, minus 12a, and that one's going to be a minus right there. And then I'm going to square this, plus 16. I'm going to go ahead and erase this because I'm going to use this area over here in just a minute. All right, so this is factored, but I'm asked to find all the zeros on this handout. So I need to set this up equal to 0, and I'm going to switch this to x just because I like to use x with quadratic formula. I need to use quadratic formula for this one. So let's do our a value is 9, our b value is negative 12, and our c value is 16. So quadratic formula x equals, it's going to be the opposite of b, which is 12. I'm not going to put the formula here. We're just going to go ahead and start plugging in. Plus or minus square root, this squared is 144, minus this times 4. 9 times 16 is 144, and then 144 times 4 is 576. Okay, and then all of that is over 2 times a, so that's 18. All right, 144 minus 576 is negative 432. Go ahead and fill that in. Negative 432 over 18. So I need to think about the number 432 and think, okay, are there any perfect squares that are factors of 432? And so 144 divides into 432. So I can rewrite this as square root of negative 1 times square root of 144 times square root of 3. And then I can rewrite this, take out the square root here, that's 12. Square root of negative 1 is I. So this right here is 12i root 3. So let's write that. X equals 12 plus or minus 12i root 3 over 18. Now, because I have a 12, and an 18, I can simplify these by dividing by 6. So this would be 2 plus or minus, divide that one by 6 also. And then that divided by 6 is going to be 3. All right, so if I set this up equal to 0, 3x plus 4 equals 0. So x equals -4/3 or -1 1/3. And then my other two are x equals 2 plus, and I'm writing this a little bit different just so you can see that there are two factors here. So I use the plus for this one. And then x also equals 2 minus 2i root 3 over 3. So here's one root, here's another one, and the last one. So there's 3 roots because it's cubic, that means it has 3 roots. So let's move on. So here we have another cubic polynomial, which means that we're going to have 3 roots, but this time it's not a binomial, it's a 4-term polynomial. So we need to figure out how we can factor this. Remember earlier when we had 4 terms, I told you that if the ratio of this first coefficient to the second coefficient is the same as the ratio of the third one and the fourth one, you can group it. So I have a 1 right here. 1 to 2 equals -5 to -10 because they both equal 1/2. So that means I can group these. So I'm going to make these 2 binomials like this. That's not factored. I still have to factor it. I'm going to take out a greatest common factor from each one. This one would be x squared. And then I have x plus 2 in parentheses. This one I'm going to take out a -5 so that I have x plus 2 in my parentheses. One of my factors is x squared minus 5. The other one is x plus 2. I'm asked to find all the zeros, so that means I have to set this up equal to 0. X squared minus 5 equals 0. X squared equals 5. So that means x is going to equal positive or negative square root of 5. And I can leave it like that. So positive root 5, negative root 5. That's 2 of my roots. The other one is going to be x equals -2, because when I set this up equal to 0 and solve for x, I get -2. So those are my 3 roots. Okay, 16, I have another 4-term polynomial. And, excuse me, and 1 to 3, oops, 1 to 3 does equal -4 over -12. That equals 1/3. So I can group these. When I group them, take out greatest common factor. This one's going to be an x squared again. Oh yeah, okay, I'm sorry. I was thinking I did something wrong, but I think this is right. I have an x plus 3 in parentheses. And then this one I'm going to take out a -4. I'll put it right there. -4. And so then I have x plus 3 in parentheses. And so I know one of my factors is x plus 3. The other one is x squared minus 4, which can be factored again because this is a difference of 2 squares. So then I can rewrite this as x plus 3, x plus 2, x minus 2. So that tells me that my x-intercepts are at -3, -2, and +2. So these are my zeros right here. Again, I have 3 of them because I started out with a highest exponent of 3. Okay, so the last one, I included a statement here that -1 is a root of this polynomial. 1 to -4 does not equal 1 to 6, so I can't group this one. What I need to do is I would need to use rational root theorem to come up with some possibilities for roots. But in this one, we're just given the fact that -1 is a root. Now, if -1 is a root of this, that means x plus 1 is one of my factors. So I know that x plus 1 is one of my factors. To find the other factors, the first thing I can do is divide this by x plus 1. Well, let's use synthetic division to do that. So if I'm using x plus 1 as a factor, that means I'm using my -1 here as the root. And then I'm going to use my coefficients. I've got 1, -4, 1, and 6. And when I use synthetic division, I should end up with a 0 remainder. Okay, so let's bring down our 1. That's going to be -1, -5. It's going to be 5, 6, -6, 0. And I do, in fact, end up with a 0 remainder. When I divide by x plus 1, what I end up with is x squared minus 5x plus 6. So when I factor this, I get x plus 1 times x squared minus 5x plus 6. So this times this, because when I divided, I got this. This binomial times this trinomial equals this right here. Now, I'm not finished because I can still factor this, and I don't need to use quadratic formula this time. This is a trinomial that I can factor into two binomials by looking at the 6 and the -5. What two numbers multiply to get positive 6, but add together to get -5? That would be -2 and -3. So because I'm told -1 is a root, that makes it a little bit easier because I can just divide by x plus 1 and then find out what that equals and then factor that. If I'm not given this part, what I would do is I would take my 6 and I would think, okay, what are the factors of 6? 1, 2, 3, and 6. And then I need to divide them by this first coefficient. That's 1. So 1, 2, 3, and 6 are the possible roots plus their negatives. Well, -1 happened to be one. We didn't have to do that because we're given the -1 is a root. So these are my factors, which means my x-intercepts are -1, 2, and 3. All right. And that was the last one on this worksheet. You're not going to have anything like this in your rational expressions, but I did want to show you this because you will see this again in the future. So we have done a lot in this handout. We talked about the fact that you first, every time you need to factor polynomials, the first thing you want to do is see if there's a greatest common factor and take that out. Makes it easier to deal with. We've done trinomials where a equals 1. We did trinomials where a is greater than 1. We talked about difference of squares. We did sum and difference of cubes where we had to use quadratic formula on those to find those imaginary roots. We did grouping where we had 4 terms, and we talked a little bit about rational root theorem. If you want to look at rational root theorem more closely, I did share recently a Khan Academy video on rational root theorem. It's a really good video. So I think that'll do it for this lesson. Don't forget, if you're watching this as part of the week April 27th, don't forget to text me a picture of your work for credit. Thanks a lot.